Bismillah ar-Rahman ar-Rahim. Now we'll continue doing this section 4.3. We finish this question. Now we'll go to the next one. He wants the local minimum of this function occurs at, so I need the x values where you have the local minimum. Okay, so first we'll find the domain. What's the domain of the function? I need x to be positive. Okay, so now we need to find f prime. F prime will be what? 1 minus 1 over 3x minus 2 over 3 times 1 over x. In other words, I have 1 minus x over 3 minus 2 over 3x. Make a common denominator, make this over 1. So you have 3x. I have 3x over 3 is x minus x squared minus 2. Can take minus common factor. I have x squared minus 3x plus 2 over 3x, which is equal to minus x minus 2. Okay. Now, if I make f prime equal 0, I have x equal 1 or x equal 2. So put the number line starting from 0. At 0, the function is not defined, so we don't care about it. This is 1. This is 2. Take a value to 0 and 1, like half. It will be negative, 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 over positive. So the answer is negative. This is negative. 1 and 2, 3 over 2 will be negative. Here is positive. Here is negative. So, and the denominator is positive actually everywhere. That will be positive. More than 2, it will be negative, positive, positive. So the answer is negative. So it will be negative. So it's decreasing, increasing, decreasing. I want what? Local minimum. Local minimum will be at 1. I have local minimum. At x occurs at x equal 1. Okay. Next one, different function. I have a product of two functions. The numbers relative maximum points. You want the points. How many points we have? Relative maximum and relative minimum points in this function. Okay. So the domain of the function or real numbers. We have no restriction in x. Okay. So I'll find f prime. Product rule. I have 5x4. That will be 4x to the power minus 1 over 5 times x minus 1 squared plus the first times the derivative of the second, which is 2x minus 1. So I can take 2 common factor, x minus 1 over 5. What's the remaining? 2. Oh, don't forget x minus 1. Also, I can take it as a common factor. So the remaining is what? 2 x minus 1. Yeah, plus 5x. Okay, that will be 2x minus 1. 2x plus 5x, 7x minus 2 over x to the power 1 over 5. Okay, critical numbers. F prime equals 0. So you have x equal 1 or x equal 2 over 7. F prime does not exist. I have x equals 0. So we'll put the real number line. That will be 0, 2 over 7, and 1. I have to check the sign now. Take a value less than 0, negative. It will be 2 times the negative times the negative over the negative. That will be negative. Between 0 and 2 over 7, take 1 over 7. That will be negative. Negative over positive. That will make it positive. 2 over 7 and 1, take 3 over 7. So you have 3 over 7 minus 1, that is negative, positive, positive. So that is negative. More than 1, 2, positive, positive, positive. So I have positive. So it's decreasing, increasing, decreasing, increasing. Yeah, I want the points. So we have local minimum. We have local maximum. We have local minimum. Okay. So if you want to find the points too, yeah, we can find the points. This will be 0, 0. Here I have 2 over 7 and f at 2/7. Here I have 1 and 0. So you have different points. So the number of points, capital M, for the local minimum extrema, relative minimum. No, M is the maximum. Maximum I have 1, but N I have 2. Yeah, I have two local minimum or relative minimum. Who cares? So 2M plus N, that will be 2 plus 2, which is 4. Okay. This function has a local maximum at this, or local minimum, or local maximum. Yeah. So first, what's the domain? The domain of f. I have this greater than or equal to 0. So I have absolute value of x greater than or equal to 1. So x less than -1 or x greater than or equal to 1. Okay. Let us find f prime, product of two functions. It will be 2 square root x squared minus 1 plus 2x minus 7. Here I have 2 square root x squared minus 1 to x. This is cancelled. This is over 1. So I have square root x minus 1. And the numerator I have what? 2x squared minus 1 plus 2x squared minus 7x. Is it? Yeah. Okay. So that gives me what? 4x squared minus 7x. 4x squared minus 2 over square root x squared minus 1. That gives me 4x. I have x. Yeah. This is minus 2. This is plus 1. So I have minus 8x plus x minus 7x. Good. So critical numbers. I have what? F prime equals 0. So I have x equal 2. In the domain, yes. X equal minus 1 over 4 is not in the domain. So this is out of the picture. If prime does not exist, these are endpoints. I have x equal plus or minus 1. So I plug it. I have minus 1. And I have 1. And I have 2 also. 2 is there. This is out of the picture. But I have minus 1 over 4 somewhere here. So this is not in my domain. Okay, take a value less than minus 1. Minus 2 will be negative, negative. That will be positive. More than 3 over 2, 1.5. Positive, negative, that will be negative. More than 2, it will be, yeah, positive. So I have increasing, then there is no domain, decreasing, increasing. So I have local minimum. Here I have local minimum at x equal to. That's it. That will be my answer. This function now have trig functions over this interval. So what's the domain? The domain is, this is the interval where I will work out. So f prime. F prime is what? Minus 2 sine x plus 2 cosine x times minus sine x. I can take 2 minus sine x common factor. I have 1 plus cosine x. Yeah, I can check. Yes, everything is okay. So I make this equal 0. So I have sine x equal 0 or cosine x equal minus 1. So I have x equal 0 and x equal pi over 2 or pi. And I have x equal pi. So we'll put the 0, we'll put the pi. It's close actually. And this is 2 pi. Take a value between 0 and 2 pi. Don't forget this is your f prime with the minus sign. Okay. Take pi over 2. So I have negative. Here I have positive. So it's negative. Take 3 pi over 2. That will be positive, and that will be positive. So the answer is positive. So decreasing, increasing. So you have local minimum here. But what the question, he doesn't want the x value, he wants the y value. So you have local minimum at x equal pi. So it will be y. It will be f of pi 2 cosine pi plus cosine square pi. It's minus 2 plus 1, which is minus 1. So that will be ours. Yeah. The sum of values of n, the interval which the function has a relative extrema. This function. Okay. When you say the relative extrema, it means you include both relative maximum and relative minimum. Okay. And this is the interval. So I'll find f prime. That will be 2 cosine 2 pi times minus sine 2 pi times 2, minus cosine 2, what is pi? Cosine 2x, sorry. 2 cosine 2x sine 2 pi times 2. So it is what? This is 2. This is the double angle. So you have minus 2 sine 4x. I want this to be equal to 0. So I have 4x equal n pi. So x is n over 4 pi. And I have this interval. Okay. If n is 0, I have x equal 0. Not includes, I have an open interval. N equal negative, not included. Okay. N equal 1, I have x equal pi over 4 included. N equal 2, I have x equal half pi over 2 included. N equal 3, x equal 3 pi over 4 included. N equal 4, x equal pi included. N equal 5 pi over 4 included. Okay, 3 pi over 2. N equal 7. N equal 8. 2 pi, not included, and so on. So I have this interval. This is 0, pi over 4, pi over 2, 3 pi over 4, pi over 4, 3 pi over 2. Two pi. Yes. And this is my function. Now take a value between 0 and pi over 4, or take pi over 8. So I have negative. Take a value between pi over 4 and pi over 2. I will take what? Yeah, 3 pi over 8. That give me, yeah, I'll get 3 pi over 8. So it will be 3 pi over 4. Yeah. Here I'll take pi over 8, because this is 2 pi over 8. Here I have 4 pi over 8 and 2 pi over 8. I have 3 pi over 8. 3 pi over 8, that will be 3 pi over 2, which is negative. So that's positive. Negative, check the points, yeah. It will be like that. Oops. Yeah, this is positive. Check points, yeah. So how many relative extreme? We have all of them relative extreme. Either local minimum or local maximum, relative minimum or relative maximum. So what is the sum? I have the one with the 4, this and this and this. 12 plus 4, 16 pi over 4 over 2. I have this with this plus 4 pi over 2 plus 3 pi. So I have 4 pi plus 2 pi plus 3 pi. That is giving me, what is it? Pi plus 4 plus 12, 16. I have pi over 2 plus 3 pi over 2. That is 4 pi over 2. And pi, not 3 pi, sorry. This is pi only. Since I don't have 2 pi, 2 pi is not in the, it's an open interval. So that'll give me 7 pi. Yeah, that'll give me 7 pi, which is this. Okay, this function is this. How many local extrema values does f prime have? So I'm working with f prime, not with f. So I'll define g of x to be f prime, which is what? 2 over 3x cubed plus 3x squared plus 4x minus 1. This is what I want to find, how many local extrema have g of x. The domain of this, the domain of g is all real numbers. It's a polynomial. So what is g prime? It will be 2x squared plus 6x plus 4. I can take 2 common factor. I have x squared plus 3x plus 2. In other words, yeah. So I'll put minus 1 or minus 2. Minus 1, take a value. Minus 3, it will be positive, negative, positive. So I have how many? 2. I have 2 local extreme, which is this. Happens that x equal minus 1, x equal minus 1. Yeah. This is a tricky one. He wants the number of local extreme values. Yeah, I have f prime. This is the interval I'm working with. 4x cubed minus 6x. So that will be 2x. I have x squared, not x squared, 2x squared minus 3. So f prime equals 0. So I have x equals 0 or x equal square root 3 over 2. Yeah. We'll put the number line. This is 0. I have minus square root 3 over 2 and square root 3 over 2. And this is my function. Okay, take a value before minus square root 3 over 2. We'll take minus square root of 2. Or yeah, it will be negative. This is positive, so that is a negative. Minus square root 3 over 2 and 0. I will take minus 1. So that gives me negative times negative. That is positive. With 1, I have positive and then negative. That is negative and positive. So it's decreasing, increasing, decreasing, increasing. So I have relative minimum here, relative maximum here, relative minimum here. So I'm expecting 3. No, it's not 3. They are 2. Why? Because if we check if at 0 is minus 1, but if you notice f of minus square root 3 over 2 is equal f of square root 3 over 2. This is all of them even. All of them is an even power. So they are the same. And if you look at the graph, you have, yes, one here and one there, but the y values is the same, the one y value, and this is another one. So I have actually 2 relative extreme, not 3. Since I'm talking about the y values, it's a tricky one. Okay, now I need to find, yeah, he's talking about local minimum and increasing, and he put these 2 ideas in one question. We'll do the same. What's the domain of f? R minus 0. So you have point of discontinuity, which is x equals 0. Find f prime. What will be f prime? It will be minus 1 over x squared minus 2 over x cubed. So I have over x cubed. I have what? Minus x minus 2. I have f prime equals 0. So I have x equal minus 2. 0 is point of discontinuity. So I have minus 2. And this is 0. Okay, so check before minus 2, take a value, minus 3. It will be positive over negative. That is negative. Take minus 1. So I have negative over negative, that is positive. More than 0. take a value like what? Like 1 will be negative. Okay. So it's decreasing, increasing, and decreasing. So you have local minimum here, and no local maximum here. No local maximum, since at x equals 0, the function is not defined. So you have a local minimum, yes. Increasing from -2 to 0, yes. Two local maximum, wrong. No local maximum, yes. Decreasing, -2 and 0, wrong. One local maximum, no. Increasing -infinity to -2, no, it's decreasing. Oh, so this is the answer. Yeah. If the graph is this function has a local minimum, when it says has a local minimum, means you have a critical number here. So critical number at x equal 1, since the function is defined. So I have f prime at 1 equals 0. Cannot be the sum of x. They have this point is the point of the function. So I have f at 1 equal 1. Okay, now we need to find a and b. F of x is this. So I need to find f prime. F prime will be what? 2 over 3. Yeah, x squared plus 2ax minus 4 over 3. I know in f prime at 1 equals 0, I can find a, since a is the only missing value. So I have 2 over 3 plus 2a minus 4 over 3 is equal to 0. So I have what? 2a equals 2 over 3. So a equals 1 over 3. Okay. I have f at 1 equal 1. That implies 2 over 9. A is 1 over 3 minus 4 over 3 plus b plus 1 equal 1. This is cancelled. So b equal what? B equal -2 over 9. This -1, take it to the other side, plus 1. So I have 7 over 9. So 3a plus 9b will be 1 plus 7, which is 8. So that will be the answer. If the function has a relative minimum at 0, 0, means f prime at 0 equals 0 and f at 0 equals 0. And they have relative maximum, so f prime at 2 equals 0 and f at 2 equal to. I have 4 equations, 4 unknowns. We can work it out. So what is f prime? 3a 3x squared plus 2a 2x plus a1. Okay, f at 0 equals 0. So I have 0, 0, 0, 0 equal a0. F prime at 0 equals 0. So you have a1 equals 0. Or 0 equal a1. No difference. Now I get rid from a0 and a1. Now I need to find a2. So f at 2 equal 2. I have what? 2 equal 8a3 plus 4a2. A1 and a0 are 0. It's okay. F prime at 2 equals 0. So I have what? 12a3 or 0. 12a3 plus 4a2. Subtract them. I have 2 equal -4a3. So a3 is minus half. Plug it here. So I have 2 equal -4. Yeah. a3 is minus half, so it's -4 plus 4a2. So a2 will be 6 over 4, 3 over 2. Yeah. So this is a2. This is a3. This is a0. This is a1. What he wants a3 plus a2 plus a1 plus a0. That will be -half plus 3 over 2 plus 0 plus 0. That will be 1. That will be the answer. One statement. Is true about this function? Yeah. He gave me a function like this, and he's talking about the domain, increasing, decreasing, passes through the origin. This is not correct. Since f at 0 Tan inverse of 0 is 0. It will be e to the power 0, which is 1. So this is not correct. Okay, let us find increasing or decreasing. Yeah, what's the domain of the function? Domain of the function from minus infinity to infinity, no restriction, or r, no restriction in x. Let me find f prime, e to the power tan inverse of x times derivative of tan inverse, which is 1 plus x squared. If you notice, it's always positive, and this is always positive. So the function increasing all the way. Increasing from minus infinity, it's always positive. Yeah, so it's increasing in its domain. Decreasing, no way. The domain, this, no. The range 0 to infinity, no. Okay. Yeah. What should do exactly is true about this function. Again, it's a strange function. He asked about increasing, decreasing, relative minimum. He wants me to do this test, first derivative test. Okay, what's the domain? The domain of the function, minus 1 and 1. This is the arc sine of x. So, I need to find f prime. That will be 1 minus 1 over square root 1 minus x squared. In other words, it's square root 1 minus x squared minus 1 over square root 1 minus x squared. That will be f prime. Is it? Yeah. So now, if I do the calculation, make this equal to 0. So I have square root 1 minus x squared minus 1 equals 0. So I have this. Yeah. I have square root 1 minus x squared is equal to 1. So 1 minus x squared is equal to 1. So x is equal to 0. Okay. So let me put minus 1. This is minus 1. This is 0. This is 1. Okay. Before minus 1, this function. Between minus 1 and 0, take minus half. This is positive 1 minus 1 minus 1 over 4. This is square root 3 over 2 minus 1. Look, f prime at I took a value like minus half. That will be square root 1 minus 1 over 4 minus 1 over square root 1 minus 1 over 4. This is negative, since 1 minus this square root 3 over 2. Oops. This is square root 3 over 4, 3 over 2, minus 1, 3 over 2. So it's negative. So this is negative, and the same thing for half. F prime at half, since I'm using x squared, is the same as f prime minus half. So it's also negative. So the function is decreasing from minus infinity, minus 1 to 1, correct. Has the relative minimum at 0? No, it's decreasing. No relative minimum, no relative maximum. Increasing, no. Decreasing to this, no. So the answer is A. We said this function reciprocal statement is false. You want the false statement. Work out the function. The domain is all real numbers. Let me find f prime. It will be 2 over 3 x squared minus 4 to the power minus 1 over 3 times 2x. So that gives me 4x over 3 cube root x squared minus 4. Numbers have x equal f prime equal 0, have x equal 0, and f prime does not exist. Give me x equal plus or minus 2. So plug it. I have minus 2, 0, 2. And this is my function. Okay. Take a value less than minus 2, minus 3, it will be negative. 9 minus 1, this is positive, so that's negative. Minus 1, it will be negative over negative, that is positive. 1 positive over negative, negative. More than 2, that's positive. So decreasing, increasing, decreasing, increasing. If it has the local maximum value of x equal to x minus 2, no, it has a minimum. Here I have local minimum. Here I have local minimum. Here I have local maximum. Local minimum at x equals 0, no, the opposite. Local minimum at x equal to x, yes, yes. Local maximum, yes. No asymptotes, no asymptotes. Actually, the function is defined everywhere. Absolute minimum value, but no absolute maximum. I will need to graph the function to do this. Let me concentrate about 4.3. Increasing minus 2 to 0, yes. 2 to infinity, yes. Decreasing minus infinity to minus 2, and 0 to 2. Yeah, so this is the negative. This is the wrong one. Which the following statement is false. If f prime equals 0, then if it has a local maximum minimum, no. Take this function, x cubed, f prime, give me 3x squared. So f prime equals 0, at 0 equals 0, but no local maximum or local. So this is wrong. If it's the local minimum maximum prime exists, then f prime equals 0, yes. Differentiable, yeah, this is the Rolle's theorem. There's the number c. C between in this interval. Yeah, there's the function, yeah, this and this. Yeah, all of these are, yeah, positive increasing, f and g, positive and increasing. Positive means f is positive. Increasing means f prime is 0, f prime is positive, g is positive, and g prime positive. What will happen to f and g? I check f or g prime. That will be f prime g plus f g prime. I need all of these conditions. This is positive, this is positive, this is positive, this is positive. So all of this is positive, so it's increasing. Yeah, this is the last one. This is the graph of f prime of a continuous function. So the function originally is continuous. Now he's giving me the graph of f prime. The graph of f prime. Now we need to check which statement is true. Okay, inflection point, this is 4.4, we leave it. Okay, now we have the graph of f prime. So if f prime is positive, the function is increasing, means f is increasing. If f prime is negative, then f is decreasing. Since they have the function of f prime, so if it is above the x-axis, it's increasing. So it's increasing here, decreasing here, increasing here, decreasing here, increasing here. Okay, decreasing with the interval 0 to 2. 0 to 2, it's increasing. Hold on, this is wrong. Okay, local minimum at x equal 4. At x equal 4, at x equal 4, it was decreasing, then increasing, decreasing and increasing. Yes, this is the local minimum. At x equals 6, it was increasing before 6 and decreasing after 6. So it's local maximum. This is wrong. If it's increasing with this interval, 0 to 2 increasing, yes. 4 to 6 increasing, yes. 6 to 8, no, it's decreasing. So this is wrong. Local maximum at x equal 2. At x equal 2, I have increasing, then decreasing. This is at 2. So this is correct. X equals 6. Yeah, f prime is not defined, but I have continuous function, so it's defined. Everything is defined at the original function. This is what I care about. At x, before x is increasing. This is before 2. Before 6 is increasing, and after 6 is decreasing. So I have local maximum at x equal 6. Yeah, that's the end of 4.3. Let me stop the recording. Yeah. Thank you.